Hi, hi. My name is Mtamze Paul, and I'm presenting on the uh, trustworthy deep learning techniques for credit risk assessment. Yes, this is the presentation I'm going to follow. I'm going to be following this particular presentation, where I'll have the introduction, related works, problem, research question, contribution, all that. So, credit risk assessment. This refers to the process of evaluating a borrower's creditworthiness. Of course, inaccurate assessments have quite a significant financial consequences, leading to loan defaults and losses. So, of course, deep learning models. Deep learning is a powerful technique within the field of machine learning, and it utilizes artificial neural networks with multiple hidden layers, allowing these models to learn complex patterns from larger data sets. So in this particular paper, we are going to be exploring the option of using a hybrid model that is going to combine the LSTM, the MLP, and the autoencoder. So this is some of the works that have been done. This paper was a credit risk prediction model using a hybrid deep learning based on a best algorithm by Christian. Yes, and this paper investigated the combination of CNNs with the SVMs, RF, and the DT. Another paper was, of course, interpretable machine learning for explainable credit risk assessment by Ariata. And of course, this paper is providing a broader overview of interpretable machine learning techniques for credit risk assessment. So the problem is to establish or to enhance trust in deep learning models used for credit risk assessment. And of course, this research explores the hybrid deep learning approach. And of course, um, um, the hybrid is going to be a combination of the LSTM, the MLP, and then of course the the autoencoders. So the challenges that are experienced by other hybrid models is that I went through. Some of them included the computational cost. Yes, so the computational cost of other models was a bit high. Also, there was an issue of the complex and interpretability um, of other models. Yes, and then I believe I'll be able to solve some of these issues that were experienced by other models. Then the objective of this paper is to, of course, implement deep learning models for credit risk assessment, build a hybrid model. That will be my main contribution. Build a hybrid model that is going to combine the LSTM, the MLP, and the autoencoder, and of course to apply explainable AI on the models. And for this case, I'm going to be using the line explainable model. So my contribution is mainly going to be the building of the LSTM, the hybrid, which is the combined the LSTM, the MLP, and the encoder, and of course the application of explainable AI, that is LIME, on the LSTM, MLP, and of course the autoencoder. So the methodology I'm going to use is going to be, of course, the data set that we received from UCI. And then we do EDA. Yes, we do EDA. Then we do data preprocessing. Then we do implement SMOT to address the issues of imbalances in the data set. Yes, and then we implement the machine learning models. After that, the implementation of the machine learning models is mainly to establish a baseline for performance and comparisons. Then we do implement the deep learning models. We're going to explore the effectiveness of the three models. Yes, that is the LSTM, the MLP, the autoencoders for credit risk assessment. Then, of course, shall implement LIME, yes, on the models. Then we shall build our model. We shall build our hybrid model combining the strength of the LSTM, the MLP, and the autoencoder. Yes, we shall build that, and of course, this will be the aim of this will be to improve the accuracy and robustness. Yes, and of course, we shall do the evaluation, the model evaluation. Then, of course, the evaluation will be based on the careful validation where we shall be able to evaluate the performance metrics like the accuracy, precision, recall, F1 score, AUC score, and of course the confusion matrix, which we shall generate. Of course, then we shall be able to provide the explainability for our model and then generate an output. So the data set, like I said, was from UCI. Data set was a study that was conducted in Taiwan in 2005. And of course, the repository has over 30,000 data points, 23 features, and some of the features include a default payment for next month, education, sex, age. Yes. So we did the EDA. And the EDA, like you can see, we have the histogram that shows the age distribution in the credit data set. Yes, and of course, we start the majority of the customers are between the ages of 25 and 40. Then we have a stacked bar chart that shows that the distribution of the credit risk, the credit limit across the different payment statuses, and categories from 2 months before. Then we have the heat map, which of course is showing us the relationship between the different features. Yes, and of course we can note that, of course, you can note that there's a strong positive correlation between the amount of a bill statement, and of course we see this. When you think about it, it actually makes sense that a customer's bill amount in 1 month will closely be the same as that on the next month. Then we have the relationship between the credit limit versus the age, then of course which was colored then by the payment status for 2 months ago. So of course the scatter plot visualizes the relationship between the limit and the age with points that of course you see are colored here by the customer's payment status. Of course the plot indicates that there's a potential connection between higher credit limits and of course the instances of late payments. Then also we also have the box plot. Yes, the box plot that is also part of our ED. So the model that we generated, or the model that we built, this is the model. Yes, the hybrid that I created. This is the architecture of the model, and we chose to use the LSTM because of course we know LSTM excels at capturing sequential data. Yes, making it ideal for credit risk model. The MLP is also powerful at learning complex and nonlinear relationships between credit features like income. Then also the autoencoder, we know the autoencoder can learn efficient representation of credit features and potential identifying hidden patterns, and of course improving performance of the hidden patterns. Then the results. So the hybrid model, of course, it shows here that its accuracy, if you look at it carefully, compared to other accuracies, it doesn't have the highest accuracy, but of course, it performs significantly better when you look at the precision and the recall and the F1 score. And that given that the precision and the recall are more critical in classification tasks involving default predictions, where false positives and false negatives have significant consequences. So we see that the hybrid model actually performs way better than all other models in the video. So we and of course, like I mentioned earlier, we implemented machine learning models to kind of create a baseline for our model performances. Yes. So we did explainable implemented Lime. Yes, we implemented Lime on each of the models, and of course we were able to generate some pointers. For example, on the MLP, the customer's credit limits, the customer's credit limit is low, pushing of course the model towards the default prediction. Yes, as you can see in the green, and then we see on the side of See on the confusion matrix, yes, for the MLP that the model, the MLP model is severely underperforming in underlying fraud cases. It appears to be biased towards the major class, as you can see there very clearly. Then, of course, this could be a serious issue for credit assessment. Yes, that is if we're using the MLP alone, right? Yes. So we proceed to the hybrid. Yes. Now the hybrid model, the hybrid model, as you can see, giving us some insights. For example, is the on the limit balance uh, shows that the customer's credit limit is low, pushing the model towards the default prediction. That is now, as you can see on the green, on the green. And then we see that the customer's payment status is what? Customer's payment status is contributing less. Yes, it's contributing less to the prediction. So in a nutshell, we see that the hybrid model is performing way better than all other models, and of course, incorporating explainability in the techniques improves the trustworthiness in decision making. So, thank you very much.